Differential equations are equations that have derivatives in them. Here we have 4 examples of differential equations, 2 on the left, 2 on the right. And they are enormously important in modern mathematics and physics because differential equations are what help us understand the dynamic evolution of a system. So of course, at the beginning, we'd like to know about how to categorize differential equations, how to recognize them, how to approach them, and what to call them when we see one. So here we have 4 examples, right? The first one, we have the double derivative of x with respect to t. And then we have another term here which has a single derivative of x, and then another term where x is sitting alone with no derivative. And then on the right hand side, I've got a term where we don't see an x, but we do see the independent variable t with respect to which we are differentiating x. And of course, in this case, we presume that x must be a function of t. So this is a function of one variable, right? And so this is a differential equation which we call the ordinary differential equation. What happens if we have more than one variable? So on the right hand side, we have the function u, which is differentiated with respect to x on the left hand side, and on the right hand side we see that u is differentiated with respect to t. So u, implicitly understood, is a function of 2 variables which are t and x. And this type of equation, which contains functions that are functions of 2 or more variables, leads to derivative operators which are not ordinary derivatives, but they are partial derivatives. So this type of equation right here, the one I've underlined just now, is an example of partial differential equations. So we have ordinary differential equations, and which are the equation here, here, and here. And then we have partial differential equations, whose example we have here. Now, one thing we notice in the top equation on the left and the bottom equation on the left is the fact that there is the first order derivative missing on the bottom equation. And then on the right, instead of having a function of t, we have 0. So the equation at the bottom contains no term without x or the derivative of x. This is what we call a homogeneous system or homogeneous differential equation. If we do have a term which does not contain x or the higher order derivatives of x, like the one at the top, this is called inhomogeneous differential equation. Both equations are called linear differential equations, linear. So what does linear differential equation mean? It means it does not contain terms which are in the nature of x squared or x times d dt of x. That means the power, that means whether you square it or cube it, etc. In that sense, the power of each term in the differential equation, the power of x or the derivative of x, or they are combined, their power will be at best 1. So terms like x squared, x times the derivative of x, or the double derivative of x, or x squared times the derivative of x, these types of terms are not allowed. So one of the example of nonlinear differential equation is the one we have here, at the bottom right corner. Here we have dx dt whole squared. This is a nonlinear differential equation. The highest order of derivative that occurs in an equation is called the order of that differential equation. So for example, in this case, the order is 2 because the highest derivative of x is of order 2. This one is of order 2 as well. The top one on the right, it is a second order differential equation because the highest order of derivative is 2. However, even though the differential equation is nonlinear, the one we have in the bottom right corner, this equation contains the first derivative as the highest order of derivative in this equation. So this is the first order differential equation. So what have we learned in this video? We've learned there are two types of differential equations. One is ODE, ordinary differential equation, where we have functions of one variable. And then we have PDE, which contains functions of more than one variables and therefore involves partial derivative. We've learned about the homogeneous and inhomogeneous differential equations. That means the functions are not present in all terms. The functions that are differentiated, the functions that are dependent, are not present in all terms. Then we have learned about linearity and non-linearity, and finally the order of differential equation. That's it for now.